Hello all, my name is Rahman and welcome back to my YouTube channel. So guys, in this video we are going to talk about the concept of soft margin in support vector machine. So guys, if you remember in the last video we have talked about the kernels. I have given the introduction to kernels and I have talked about how to handle the non-linearable data, and I have talked about why we use the kernels, how it works, how it used, etc. I have talked about other lot of things in the kernel in machine learning in support vector machine. Now guys, in this video I am going to talk about the soft margin in support vector machine. So guys, this topic is new in support vector machine, but guys, soft margin in support vector machine allows some misclassification to happen by relaxing the hard constraints of support vector machine. Soft margin in support vector machine is implemented with the help of regularization parameter C. Okay, and then it tells us how much misclassification we want. Regularization parameter in the brackets C is what it does is it tells us how much misclassification we want to avoid in the classification. Okay, so guys, that's why I have bring the topic of soft margin in support vector machine. Now guys, first there are two major reasons why the soft margin classifier might be the superior. So guys, one reason is your data is not perfectly linearly separatable, right? But is very close, and it makes more sense to continue using default linearly kernel. The other reason is even if you are using a kernel, you may wind up with a significant overfitment if you want to use a hard margin. For example, let's consider this example that you are seeing on the screen, where we have a graph where we have some of the positives and some negatives, and then here we are going to give something like x2, okay, and here I am going to give something like x1. Okay, so guys, this is x1, this line is x1, so this line is x2 and this line is x1. Now guys, here a case of data that isn't currently linearly separatable, right? Now assuming a hard margin, which is that we have been using in our calculations so far, right? Which we have used in the hard margin. So guys, if you heard the word hardware and software in the computer, right? So guys, in computer there are two things, one is hardware and the software. Okay, like that only here also we have the soft margin and the hard margin, right? Assuming a hard margin, which is what we have been using in our calculations from many videos, and we might use a kernel to achieve a decision of a boundary, right? Like for example, this is immeasurable. If I show you here, like for example, if I move from here, the line starts from here and then it's going to move from here, and then I want to divide this from the minus and the plus, right? You can see here, right? We have the plus and minus. I can divide in this way, but guys, can we divide there? Okay, can we divide this by using the hyperplane line or not? No, right? So guys, here if you see, we can go something like in the black line that you are seeing is dividing. If I show you again from here to here, something like this, right? So guys, this line, the main line is dividing these two operations like positive and negatives. Now guys, what we are going to do is noting the imperfections in many drawing lines, in many drawing abilities. Like for example, let's draw the support vector hyperplanes and circle the support vectors. Right, for example, we have drawn this one, and then I am going to, okay, let's choose this one. Let's start from this plus, okay. So we have this black line going from here, something like this, and then it's going to move up something like here, something like this, right? Now, as I said, I am going to circle the support vectors. So guys, this is the support vector, this is also a support vector. So let's do one thing. Let's change this size. Okay. Now, let's start again. We are going to go from here, and then we are ending up somewhere around here, right? So now I am going to circle these support vectors. This is a support vector, this is also a support vector, this is also a support vector, this is also, and this is also a support vector here. Now let's change the size. Okay, now for the minus also we have to do, right? So let's do this again. We have to do something like this. It's going to be something around something like this, let's say. Okay, now we have this one. Now let's circle this also, circle them here, and I'm going to circle them here also. So guys, as you can see here, in this case, every single data sample for the positive class is support vector, and the only two negative class are support vector. Like for example, if I show you, these two are not the support vector, right? Because it's going from here, here, and then it's ending up here. So because it cannot touch this one, right? So guys, in the only two of negative classes aren't support vector, right? This signal to use a high chance of overfitting having happened, right? So guys, that's something we wanted to avoid. We wanted to avoid something that the main problem from that we are seeing here. So this is also a circle here. Okay. Now, since as we move forward to classify the future points, and then we have almost no wiggle room, right? So I'm likely to misclassify a new data. What if we do something like, instead of let's go back. Okay. Now guys, we have something like this, and then let's draw a new line. Now here let's draw something like this. Okay. And then what if the line is going from here to here, right? So it will be something like this, right? So guys, what if we did something like this instead of doing all of those things, right? We can also do this, but guys, what's going to happen is this plus these two, this minus is going to come here around, right? Now here guys, we have a couple of errors or violations noted by the arrows, but this is likely to classify the feature sets better overall, right? Now what you have here is a soft margin classifier, which allows for some slack on the errors that we might get in the optimization process. Now, as I said you guys, we had some errors and that we might get so we have that errors and we might get that in the optimization process, right? Now guys, for doing that one, for not coming that one, so I'm going to clear all or move this somewhere around. Right? Move it here. Let's wait. Okay. Now guys, what I'm going to do is I'm going to show you, let's try something like slack. Okay, so guys, the slack is equals to, let's give it as a symbol or something like what we say. Let's give it something like this in the form of 3 or not 3. Okay, opposite to 3. Okay, so anyhow guys, now we have this slack, this one. Now what I'm going to do is, if you remember guys, some videos before, you have used a formula known as y sub I into x sub I plus x sub I into w plus b, where we have the minus greater than or equal to 1, where we have the equals to 0, or we have the minus less than or equal to 1. So guys, let's do one thing here. Let's type something like y, and then I'm going to give here dot, let's type in something like this, y sub I, and then I'm going to give here in the brackets x sub I, and then I'm going to do this with the w, and I'm going to make the w plus b. Okay, now guys, as you can see here, we have the y sub I into x sub I in w plus b, where I'm going to use here so guys, if you remember, we have three options. One is equal to 0, one is greater than or equal to 1, and another is less than or equal to 1. So guys, I'm going to use the greater than or equal to 1. Okay, so guys, for doing, let's do something like this, greater than or equal to 1. And now guys, you can see we have the y sub I into x sub I w into w plus b greater than or equal to 1. But guys, what if we insert this slack error here in this equation, right? So guys, what if you do that? Right, so let's do also that one. Now I am going to do this something like minus slack or something like this slack. Okay, now guys, our new optimization is about the calculation where the slack is greater than or equal to 0. So guys, let's give the slack which is greater than or equal to 0. Let's give something like this. Now guys, where the slack is greater than or equal to 0, in this case, then the closer to the 0 is the slack is, okay, the more hard margin we are. So guys, the closer to the 0 the slack is, the more hard margin we are, as I said. Now the higher slack, the more soft margin is here in this case. If the slack was 0, then we would have the we will have a typical hard margin classifier, as you might guess. However, we would likely to minimize the slack here in this case. Okay, so anyhow guys, now I'm going to move here in another way, somewhere around here. Now guys, to do these things, right, we need to add to the minimization of the magnitude of vector w. So guys, for doing this one, I'm going to give something like right? Let's use it. Now we have the sum of I, and then we have the slack, and then which is going to be slack sub I. And then what we want to do is we want to minimize. I'm not going to type all of these things. Then it's going to be equal to 1 by 2 of vector W square. And then it's going to be something like the plus, and then let's give this C plus, and then it's going to be sum of I, or one, so sum of I, and then we have the slack again, and it is equals to sub I. So guys, thus we want to minimize the 1 by 2, right? So guys, as I said, if we want to minimize the 1 by 2 into magnitude of, we want magnitude of vector W square plus C into the sum of all the slacks used, and then with that we borrow in another variable where C is a multiplier for the value. Okay, now you will be asking the question like, why I have given the value, so this is why I have added here the C. Now value of how much we want slack to affect the rest of the equation. The lower the C, the less important the sum of the slacks in a relation to the magnitude of vector W. Okay, so guys, this concept is a little bit confusing, but guys, this is very important to us. Okay, so anyway guys, that's all for this video, and guys, thank you for watching this video. I hope you liked this video, enjoyed watching this video. Thank you for watching this video, and I will see you in the next tutorial. Thanks for watching. Thank you. Bye.